Mic's on. Ooh, I'm loud too. How's everybody doing? Good? Enjoying reInvent so far? Yeah? I can see some nodding heads. It's kind of cool. So thanks for joining us today, early in the week of reInvent. Hopefully it's been a good day and a half so far. In our session today, we're going to be talking about building APIs and how to choose the best API solution and strategy for your workloads. Over the years, we've seen customers move to more modern, modular architectures because they tend to provide some benefits like improved scalability, performance, and the opportunity for teams to innovate at different rates. Often you're using APIs to integrate between those modular systems. Or you're building something that's providing data to like a mobile application or a web app, and it needs to get data from the server, right? So the API is that integration where we can decouple the different parts of the system. So today we're gonna go through some of the design decisions that we made in building an actual real-life system that you can go play with after the talk today. Everything that you're going to hear, you can take advantage of immediately as you walk out those doors. And there are a number of options in this space. We totally cannot cover them all in only an hour, but we're going to try to give you a few AWS managed options and then spend a lot of time talking about the considerations, both technical and non-technical, right, or less technical, if you will, that we made. My name is Josh Kahn. I'm the worldwide tech leader for serverless here at AWS. And joining me in a few minutes is Arthi Jagannathan, who's a principal solutions architect, also focused on serverless. So in our talk, we're going to build an extension or a plugin for a larger application that you will probably see if you go to other serverless and application integration sessions at reInvent this week. You also may see it on the expo floor. And we're going to build an extension that has a couple of APIs in it, because that's the focus of this talk, of course. We're going to go through some of the considerations we made in designing and building it out. This is a 300-level session, so we're not going to spend a whole lot of time talking about defining terms and concepts, and hopefully we get just technical enough, right, to get into some of the weeds. Our focus is on API design. But we will point to some other reInvent sessions that come later in this week where you can explore more. And there's also a resources page at the end of the talk where you can dive into all of the topics and technologies that we're going to go through today. There we go. So what we're going to build is a leaderboard service. Everybody's probably familiar with leaderboards, right? There's kind of an ordered list of names or whatever, ordered by some metric. There's actually two metrics that we're going to be keeping track of. And we're going to expose that data to a mobile and a web application. And then because many of the customers we work with are enterprises, and they like that network security boundary, right? We like when things are kind of tucked inside the four walls of a VPC. We also have an internal, what we're calling metric service, right? Which is just kind of a cache with an API sitting in front of it, if you will. And we're going to extend the functionality of this serverless video application. So again, you can take all of what you hear today and use it immediately. And with that, I'm going to hand it over to Arthi to talk a little bit about APIs and some of the considerations that we thought about in building this thing out.
Okay, thank you, Josh. So I'm going to take you through the design approach Josh and I took to build the APIs. A good API abstracts away implementation details, and abstraction is important to reduce coupling between systems. But is abstraction enough? If your service is external facing and directly consumed by end users, then your API is the product. A good example here is software as a service offerings. If your service is internal, you might have others on the team using your service to deliver the product. Good API design then is not just about good abstraction. It is important to understand the business use cases your API will support, and it is also important to make your APIs easy to understand and use for the consumers. This is really the idea behind an API-first design approach. So I'll take you through the steps Josh and I took for the Leaderboard plugin. As a first step, think about the access patterns your API needs to support. we've shared some dimensions here you can use to describe API interaction. Temporal dependency has to do with whether your client gets data immediately in response to a request or not. If yes, the interaction is synchronous, else it is asynchronous. Communication mode has to do with who initiates the data transfer. If your client gets data only in response to a request it sends out first, then the communication is one-way. On the other hand, if your service also proactively sends data out to the client, then the interaction is two-way. Examples here are push-based notifications or server-side events. Data structure has to do with whether your service returns the same payload for a given request to all of its clients or not. Clients today include web applications, mobile applications, and a variety of smart devices. Each one operates under different resource constraints and might have slightly different data needs. So this explosion of clients has given rise to front-end approaches such as backend for front-end. The idea there is to have a separate API or an abstraction layer that will customize the response sent to each client. Once you've identified the access pattern, the next step is to map it to an API architecture style. You can think of API architecture style as a set of guiding principles when it comes to designing APIs. It is a little bit like choosing an application development framework. So we've listed some of the common API architecture styles here. Each one has its own way of modeling the problem space. REST, which is the most popular choice for APIs today, requires you to define resources and methods that tell you how you can interact with them. As a consumer, I would use an SDK to integrate with the API. But as a consumer, I also need to know what the response looks like and any other requirements such as authentication needs. And this is where API documentation comes in. OpenAPI specification is a common choice to document API contract for REST APIs. GraphQL is both a query language and a runtime to fulfill queries. It encourages you to think about data and the relationship between them. GraphQL is strongly typed, so it describes data entities and operations as types in a schema file, which is then used to auto-generate client-side code. gRPC is an open-source RPC framework. It has the idea of services, where each service does one thing well, and methods that tell you how you can interact with them. Protocol buffer, or protobuf for short, is used as the interface definition language and the data serialization format. Protobuf is designed to be more lightweight and therefore more performant than using JSON or XML. As a service owner, you would define the services, methods, and messages in a proto file, which is then shared with the consumer, who would parse it using a proto compiler based on the programming language. Async API is an open source framework for message-based and event-driven architectures. Terminology here is not as standardized as the other three. It depends to a large extent on the choice of the event broker technology. The structure of the event is documented as event schema, which can then be used to auto-generate both client and server-side SDKs. So far, we've only considered access patterns, and at this point, you might find more than one API architecture meets your needs. Next, we look at some of the non-functional and API management needs to further scope our choice. API visibility has implications for how you design your security controls and how you think about API discovery and manage your domain names. Your service SLA has implications for how you design for performance and availability. For example, you might choose gRPC for low latency backend integration because gRPC uses HTTP2 for transport and a lightweight binary message format. As the number of APIs grow, it is also important to think about API management at scale. API topology is largely governed by how you're organized internally and who owns the APIs. So this has implications for whether you choose a centralized API strategy, where APIs are generally managed by a central API platform team, or whether you choose a distributed API strategy, where APIs are co-hosted with the services and owned by the service teams. As the number of APIs grow, it is also important to make it easy for your consumers to quickly find the APIs they're looking for and integrate with your service. So one way to solve this is to build an API developer portal. And finally, team skills play a large role in the choice of API architecture. If you're under a tight timeline to launch a service, you might choose an API architecture that's already running in production. First, your team is familiar with it. Second, you likely already have all the tools in place to deploy and manage the APIs. So now that we've looked at some of the non-functional and API management needs, the last step of our design process is to choose the API technology. AWS gives you multiple options to build APIs. Amazon API Gateway is a managed REST and WebSocket API. AWS AppSync is a managed GraphQL API. Application Load Balancer can be used as an API. Amazon VPC Lattice is a managed REST and gRPC API for services running in a VPC. And finally, Lambda function URL gives you an easy way to create a REST endpoint to trigger your Lambda functions. Not all services might check all of your requirements out of the box, so you might want to consider some of our partner solutions to bridge the gaps. We won't be covering Application Load Balancer today due to time constraints, but we will cover the other services that you see here. Now, as you go through these design steps a few times, you will identify design decisions that work well for common workloads within your organization. You can then take this to the next level by codifying the design decisions as reusable infrastructure as code patterns. So this will not only accelerate future API builds, but also make it easy to standardize API best practices. So now that we know the design approach, I'm going to pass it back to Josh, who will show you how we applied this to the Leaderboard API.
Thank you, Arthi. So before we go too much further, I wanted to talk a little bit about the workload that we're going to be talking about today. So this is serverless video. Serverless video is a live streaming video application that we built using a variety of serverless technologies. This is not a new AWS offering, okay? It's a demo, but it's a real working demo. You can try out. It's performant. It's scalable. We've been streaming on it actually since Sunday. And if you want to check out some of the interesting videos that people have made, we've been doing some interviews. You can either scan the QR code or visit the link in the lower right-hand corner of the screen. You'll also be able to check out some of the source code for it as well. So you'll see serverless video popping up all around reInvent, depending on which sessions you go to this week. But we think it's a nice way to kind of tie together a lot of the serverless stuff that we've been doing this year. Of course, serverless is about the operational model that you want to use. The people that built this are actually all speaking around Las Vegas this week. So we didn't want to spend too much time on operations. That's where serverless tends to make a lot of sense because we're not dedicating as many resources to the operations side of the house. But with serverless video, right, you can stream a video, and then it goes through kind of a processing pipeline before it becomes live, right? So there's kind of the live stream view, and then there's this was previously recorded view. And we use step functions to build an extensible pipeline where we can have different plugins that process that video in different ways. And these actually get orchestrated and executed in a sequential manner. So we know kind of what order things are going to happen. And each one of these event hooks kind of has a slightly different shape. So we've built plugins that do things like create a transcript of the video. Kind of an obvious thing, but you can do a lot of neat things with a transcript. You can feed it to Bedrock, Amazon Bedrock, and generate a title, sometimes with interesting results. You can also run it through like through Transcribe and create a translation of that transcript. And you can also look for people using naughty words. Okay? So our Leaderboard plugin is what we call a post-metadata plugin. The event payload that it receives has a bunch of information in it. But what's interesting to us is the channel identifier and the number of seconds that the stream lasted for, because that's what we're going to build our Leaderboard off of. Other plugins might use other things, but that's OK. So we're going to grab the channel ID, number of seconds, kind of feed that into the metric service that Arthi is going to talk about a little bit later. So working backwards, this is kind of a rough mock-up of what our leaderboard might look like in a mobile app. So we've got kind of this ordered list, either by the total number of streams or the total number of seconds a channel has streamed. And we're going to need two different APIs to build this thing out. The first is something that's external or public-facing, lives out there on the internet. Because if I want my phone to be able to connect to it, I need to have some sort of network access, of course. And when it's public, that also comes with some security caveats. Unless you want it to be a totally public and open API, but even then, you want to think about things like throttling and caching, right? So that you don't get just loads and loads of people hitting your API. The other is internal, and again, that's a little bit because we wanted to show kind of that aspect of building more internal-facing APIs, because we get asked about it a lot by our customers. This is also a leaderboard, so the data is going to change every time the application processes a new video. So we want to be able to update the data, so that when somebody pulls it open on their mobile application, they can actually see, oh, you know, so-and-so just published a new video. The rank might change. And by decoupling things using an API, we can actually start to change some of the back end if we wanted to as well. So we both have serverless in our title, so you can probably guess we used Lambda for a lot of stuff, right? A lot of building out a lot of this. But you could also put Fargate or ECS or EKS, whatever you'd like behind it, as long as that contract stays the same, because we've decoupled it from the front end using that API. So we're going to start by talking about the Leaderboard API, which is kind of the public-facing side of the house. So from a functionality standpoint, again, we have a mobile application and a web client that we're going to think about, at least for our purposes today. But maybe there's more clients in the future. We also want to be able to support real-time data use cases. Now, we'll talk about push versus pull in a little bit. We have a preference towards push. But we want to be able to keep that data up to date. And if you think back to the considerations that Arthi shared a few minutes ago, the visibility, of course, is external. There's both synchronous and asynchronous interactions with this API. And I'll talk about those again on the next slide. We'll just assume we're going to use JSON as the data type. It's convenient. And that we are going to put some sort of auth on top of this. We don't want everyone just being able to call the API, not necessarily knowing who they are. So when we think about API interactions, the front end, the mobile app in this case, is going to go load the current state of the leaderboard, right? It's going to fetch that data initially, but then it needs to subscribe to other updates. And then eventually, our leaderboard API needs to go call that internal metric service. Could we have done this other ways? Yes, absolutely. But this is a nice way to kind of demonstrate how to mix internal-facing and external-facing APIs. So to implement the Leaderboard API, we chose to use a GraphQL-style implementation with AWS AppSync. So AppSync is a managed service for building and operating GraphQL-style APIs. So there's a couple of important things here and why we chose to use AppSync. The first is that we can change what the response looks like from the server by sending in a different query. And we'll show you what that looks like in just a moment. So if the client does happen to change, maybe it wants new data or less data, we can change that just from the front end as opposed to having to make a change on the server itself. AppSync also has a built-in mechanism for subscribing to data changes. So without having to run multiple APIs or trying to get too fancy, I can use GraphQL to fulfill both of the interaction patterns that we wanted to have for this part of the application. AppSync also supports a variety of auth options. We have a fancy table in a little bit that shows you a lot of those. And when you all pull out your phones, I'll believe you're taking my picture, by the way. Just makes me feel good. Thank you for laughing. But AppSync supports things like Cognito, which is what we show here, AWS IAM auth, and then you can also use a Lambda authorizer. So if you have like an on-prem auth system or you need to do something that isn't quite supported immediately by what's there, you can customize pretty readily using Lambda. Now, GraphQL is just HTTP under the covers, but your client technically needs to know how to talk to a GraphQL server. It needs to know how to format the queries. All of the requests go to a /GraphQL endpoint, which is a little bit different from REST, where like the path actually matters in a lot of cases. So there's trade-offs there that you need to think through. Now, one other thing that I want to point out is there's this Lambda function kind of sitting there in a VPC, right? So with AppSync, in order to access the metric service, which again is private and internal, we need to use a Lambda kind of proxy type approach. So that Lambda function is associated with a VPC that has access to the service network that the metric service is available in. So AppSync works this way. API Gateway works a slightly different way that Arthi is going to explore in a little bit. So if you're not all that familiar with GraphQL, this is what a GraphQL query looks like. In this case, we're just running the list leaderboard query. We want to order by duration, and it's going to return an array of leaderboard entries. And then each one of those items has some data associated with it, and the client can specify that stuff in orange. So in this case, we're going to return the channel ID, the username, the rank, and then the total number of seconds that channel has streamed for. Again, there's only one endpoint that our client needs to know about, but it uses that GraphQL schema to understand what the query payload needs to look like. So the server is actually going to respond with the exact data fields that the client asks for. And again, if our client were to change at some point in the future, albeit this is a pretty simplistic case, it can ask for different data fields, and that's what will get returned, again, kind of in JSON format. Well, it is in JSON format. Now, this is a little bit minimal. Arthi mentioned backend for front-end patterns. There's one I'll show in a little bit as well with an analytics use case where you might have a lot more data fields that are available to you, and you only want a subset. So GraphQL can help with underfetching and overfetching challenges that you might have with REST. You get the data you want back, as opposed to having to make another request to get what you need, or maybe getting more back than what you want. But it does come with some complexity. Again, the client needs to know about it, and your team needs to understand how to deal with GraphQL. Now, if we wanted to add another client, maybe an Alexa skill, I'm probably not going to have Alexa read out all of the data that I'd see in my mobile app. So in this case, we can change that query, specify we only want the username and rank to come back. Maybe we want to even add a parameter that allows us to limit the number of entries that come back, and it will only return that data from the server. Subscriptions don't look all that different, right? A subscription query or a subscription payload kind of looks similar. We tell it, I want to know when any leaderboard updates occur. Here's the data I want back. And with AppSync, what happens is it will actually return a secure WebSocket URI that the client can then subscribe to. And eventually, then you basically have a two-way path where the server can push out data changes, and the client receives those, and it does whatever it needs to repaint. Now with AppSync and subscriptions, there actually needs to be a mutation or a change to the data in order for it to push out that data change over to subscribers. We're not going to get into the details of how that works here, but because of the way serverless video works, the event comes in from kind of the primary application, and then we update the persistent store in the background. Arthi is going to talk a little bit more about what that looks like. AppSync doesn't know that that change has happened. So we'll use a pattern that we actually have in a number of articles that uses a none data source on AppSync so that we can actually make AppSync aware of that data change, and it will then push the delta out to any subscribers. And the team has actually added a lot of very cool features to AppSync recently with subscriptions so that you can filter send data just to the clients that want it. There's some pretty cool examples out there of like other real-time use cases like NBA game scores, stock trading applications, et cetera. So we can't exhaust AppSync and GraphQL here. I'd encourage you to check the session catalog. for other sessions this week. All right, so let's talk about subscribing and polling, because I still see this kind of polling pattern a lot. And polling is basically the client says, hey, server, do you have any data for me? Do you have any data for me? Any data? Right? And it keeps going. This is a pretty chatty, expensive thing to do, but we still see this with a lot of legacy workloads. Maybe less of a problem now from a network and compute constraint perspective, but still, there's probably cleaner ways to do this. And we preferred to use a subscription pattern, which is what we talked about on the earlier slide. So essentially, the client says to the server, hey, I'm interested in any data changes, please let me know. And if that at some point happens in the future, we can push that data out. So AppSync and GraphQL is just one way to achieve this. On AWS, you can also use IoT Core, SNS, and API Gateway WebSockets to kind of create this two-way connection as well. So when we talk about accessing the leaderboard, again, we want to make sure that our client is authorized to actually have access to it. We don't want just a purely public open endpoint on the internet. AppSync supports things like OpenID Connect, IAM, Cognito, and other options. It also supports API keys. API keys are identification, not authorization, right? So be careful when you use API keys outside of dev test type environments. In AppSync, you can add authorization directives directly in the GraphQL schema. So for example, that at AWS Lambda bit at the end, that essentially says there's a Lambda authorizer that can grant a client access to this list leaders query. So when we talk about securing APIs, we wanted to give you kind of a quick snapshot of what some of the options are from an access control perspective across API Gateway. And by the way, this is the REST API variation of API Gateway. AppSync, the application load balancer, and Lambda function URLs. So AppSync and API Gateway have a pretty comparable rich set of things like IAM, Lambda auth, Cognito. But API Gateway also supports options like mutual TLS, which is very, very popular for service-to-service type authorization. And of course, because our service teams are so busy leading up to reInvent, they managed to make this slide a little bit outdated. But the load balancer team also released mutual TLS on Sunday. But it's not just about access control when we talk about securing APIs. There's also some network security and other options that you can consider. You can integrate AWS WAF or other web application firewalls with many of these options. With the Lambda function URLs, you do need a CloudFront distribution in front of it to do that. I also encourage you to look at things like throttling and caching again. You don't want a denial of wallet attack, but throttling and caching can play an important role. We also talked about how to do private integrations with AppSync, and Arthi will talk a little bit more about it with API Gateway. So when to use AppSync? So AppSync supports both internal and external APIs. We only talked about external today, but you can use private link to provide access to an AppSync API from your VPC. AppSync works really well for both sync and or async interactions using a GraphQL interface. We talked about some real-time use cases. Again, team skills are important, as Arthi talked about earlier. May add some complexity, but it often comes with a lot of benefit as well. So a couple of common patterns, back end for front end. And then this is kind of a data analytics case that's shown on the screen right now. Here we have AppSync actually go start Amazon Athena query. And then the client can subscribe to when that query is complete. So Athena is going to go run the query. It's going to go drop the results in some S3 bucket. And then we can have that S3 new object event trigger a Lambda function that mutates something in the AppSync API to send the subscription, trigger the subscription to go back to the client and say, hey, your data's ready. Here's an S3 pre-signed URL to go get the result. So AppSync works really, really well with this type of event-driven pattern or event-driven architecture, which you probably hear us talk about as well. So with that, I'm going to hand it back to Arthi to talk a little bit about that metrics tracking service.
Thank you, Josh. OK, so we've designed the metrics tracking service as a separate microservice because we anticipate more consumers for this in the future. Our marketing department, for example, is also interested in this data. But the important thing is we have a few internal consumers, and the number of consumers is unlikely to change on short notice. So let's start with the functional and design requirements. The metrics tracking service has two capabilities. It reliably persists the raw metrics published by our streaming service. It summarizes the metrics to calculate the leaderboard for the Leaderboard API service. Let's start our design considerations with the access pattern. The Leaderboard API is a near real-time workload because the leaderboard is only relevant over a short time window. So as a service, we must return this information as quickly as possible to our consumers. Today, we have just the one consumer, and unlike the Leaderboard API, our consumer is not constrained by things like unreliable network. So we are going to start simple with synchronous one-way communication and a fixed JSON payload. From an API management perspective, we still want to authenticate all the requests, even though this is an internal app, and we will be hosted in a separate AWS account. Based on these requirements, REST is a good fit for this use case. So let's take a look at the high-level architecture next. The metrics tracking service has two integration points, and so far, we've only focused on the integration with the Leaderboard API. But the metrics service is also a consumer for the raw metrics published by the streaming service, and this integration is asynchronous. Metrics are published to Amazon EventBridge, which then pushes this out to targets based on subscription rules. We're using a Lambda function as a hook to receive the metrics from EventBridge. This will then invoke our metrics tracking service to persist it. We won't focus on this async integration for the rest of this talk. If this topic is of interest to you, I recommend you check out one of our EDA sessions. Now, the last step of our design process is to make the technology choices. We need a low latency cache for the metrics tracking service, and we went with Redis. We are both familiar with Redis, and also Redis has built-in support for sorted sets, which works really well for the leaderboard use case. So that's less work for us to do at the application layer. What this also means is that our metrics service is a VPC-based service. As for the API technology, we implemented REST with Amazon VPC Lattice. So before I take you through the implementation, I will start with an overview of VPC Lattice itself. So VPC Lattice is an application networking service that simplifies network connectivity for VPC-based services. To understand what Lattice is solving for us, let's briefly go back to the Leaderboard API use case. Our consumer there is a mobile application that uses DNS to resolve the AppSync API and connects to it over the internet. If we think about the metrics tracking service, or any internal service for that matter, we still need to solve for service discovery. We can use DNS or a custom solution here. However, when it comes to the networking, there is a lot more work we need to do. So again, AWS gives you multiple options to connect VPCs. You can choose VPC peering or AWS Transit Gateway or something like AWS Private Link that allows you to expose services directly in client VPCs. But all of these options require you to configure the network routing and in some cases set up additional services such as Transit Gateway or Network Load Balancer. VPC Lattice completely abstracts away the networking. It has the concept of a logical service network. So in our case, we would create a service network for the Leaderboard plugin. And it has logical services, in our case, the metrics tracking service and the Leaderboard API service, both of which are associated with the service network. Once associated, they are registered in the Lattice service directory. Finally, the VPC of our client is also associated with the service network. When the client resolves these services, it gets back a linked local address or a unique local address if you're using IPv6, and therefore there's no special network routing needed. Behind the scenes, Lattice will send traffic between VPCs across accounts and manage translation between IPv4, IPv6, and overlapping IP ranges. It is easy to implement a zero trust architecture by integrating Lattice with AWS IAM. So the idea behind zero trust is that you don't trust traffic just because it originates from a trusted network, and therefore you authenticate all the requests. Lattice also gives you traffic shaping options such as blue, green, and canary deployments and multiple routing options. So now that we understand what Lattice can do, let's take a look at how we implemented it for the metrics tracking service. We chose Amazon MemoryDB for Redis as our low latency cache and AWS Lambda for the compute layer. As a service owner in the Lattice world, you still need to define the listener rules. That is the port, the protocol, and the targets that will process the requests. We are using a custom domain name with Lattice using Amazon Route 53. And finally, we are authenticating all requests with AWS IAM. Lattice also supports gRPC, but today you cannot use gRPC with Lambda as the target. So this is a server-side implementation. Let's take a closer look at the client experience. Firstly, if the Lattice resources are created in a different AWS account, they must be shared with the client AWS account. We already discussed the first requirement, where the client VPC must be associated with the service network. What this means for the Leaderboard plugin is that our Lambda hook that receives metrics from EventBridge and invokes the metrics tracking service to persist the metrics must be configured with a VPC that is associated with the Leaderboard service network. This also applies to the Lambda function that's part of the Leaderboard API service that is querying our metrics service to retrieve the leaderboard. Any security group rules and access control lists you have in place in the VPC still apply. For instance, if you explicitly block all traffic to and from the Lattice prefix list, your client cannot reach the services even though the VPC is associated with the service network. And finally, the ability to authenticate every request improves the overall security posture of your application. You can now perform fine-grained identity-based authorization. For example, you might want to restrict traffic to your service only from application hosted in an AWS account that's part of a particular AWS organization. Lattice today only supports IAM for authentication. But once your client meets all these requirements, the choice of compute for the service layer is completely abstracted away. It does not matter whether you're using EC2 or containers or just Lambda, as we have done in this case. So far, we've focused on APIs internal to your organization. But what about private integrations? And the same? They're not the same. Private integrations use VPC link to expose services that are private within your VPC publicly to clients outside the VPC. So how exactly you implement this depends on the choice of the AWS service. If you're using REST API Gateway as your public-facing API, you need Network Load Balancer as the target within your VPC. You get a couple of more options if you're using HTTP APIs. You can use Application Load Balancer or AWS Cloud Map, which is a private service directory, as the target. In both cases, you can still use Lattice as the API for your internal service. However, you need a proxy compute layer behind API Gateway in order to access it. And finally, Josh has already shown you how you can do this with AppSync. You would need Lambda function as the target. So let's summarize when you should consider VPC Lattice. So Lattice works well for building private APIs and synchronous access patterns. It simplifies networking between VPCs. However, the role of your networking team evolves a little bit in the Lattice world because they are now responsible for defining the service network, associating the services and the client VPCs with the network, defining auth policies, and sharing Lattice resources across accounts. The important thing is that Lattice can coexist with all your existing VPC networking configurations, so you can choose to adopt this selectively for your workloads. And that wraps up the internal metrics tracking service, and I'm going to pass it back to Josh to take you through the other APIs in serverless video.
Thank you. So we're going to talk about two other APIs that exist in the serverless video application. These are not part of our Leaderboard plugin, but we wanted to make sure that we worked some of these examples in. So the first is a channel manager API. This is the API that gets called when we want to create a new channel in the serverless video application. So this uses Amazon API Gateway. It's very much a synchronous type of interaction with the client, but there's actually asynchronous work happening here. In this case, we're also using SQS as a way to kind of govern how Lambda interacts with the downstream service. So serverless video is built with the Amazon Interactive Video Streaming, or IVS service. And there's some limits on how often we can call the create channel API. And if you've worked with Lambda before, it scales up pretty quickly, even faster after what we announced over the weekend. So we use SQS in this case as kind of a governor to slow things down so that we're not getting throttled by IVS. The channel manager uses what we call a direct integration between API Gateway and SQS. So there's actually no code that you have to write here, although it is a velocity template. AppSync actually has similar features as well, where you don't need to write custom code necessarily. You just write a resolver template, or in this case, a velocity template to interact directly with the AWS API. So here we're going to call the SQS send message API. It's going to grab part of the request payload, and then that message is sitting in an SQS queue where the Lambda service will eventually pick it up. The Lambda function runs, and it goes and creates that channel for us. But once SQS has that message, it returns back to API Gateway and says, hey, 200, I've got this. And API Gateway can return to the client at that point. So this is also what we call a storage first pattern. If you have a workload where it's absolutely really important that you don't lose the data, you might want to consider using something like SQS or Kinesis in between API Gateway and whatever is actually working on that, doing that work. API Gateway is extremely flexible, though. It supports both internal and external APIs. It can also support synchronous and asynchronous interactions. The thing to know, though, is that if you pick REST, there's kind of the REST flavor and the WebSocket flavor. AppSync has a way of kind of melding both. API Gateway, you would pick either REST/HTTP or WebSockets. API Gateway has very, very flexible back-end integrations. It supports things like mutual TLS, throttling and caching, and it also supports features like usage plans, which can be useful if you have like a chargeback model to your consumer, or maybe it's like an associate type URL. So to create the last API that we have today, we're going to extend serverless video again. So we're going to take that transcript that gets generated by the transcription plugin, and we're going to create a translation of it. Pretty simple use case. So we're going to register the translation plugin as another post metadata plugin. There's a step functions workflow that calls Amazon Translate. It does its work on the transcript and writes the result to an S3 bucket. And we can use a Lambda function URL, or FURL, to stream that translated transcript back to the client. So function URLs, as Arthi said, are great for synchronous types of interactions. You can also do streaming responses with FURLs, so faster time to first byte. And you can exceed 30 seconds. So both API Gateway and AppSync have a default 30-second timeout for their response. A FURL can actually run for up to 15 minutes, which is the max time that a Lambda function can run. Again, though, I would encourage you to put a CloudFront distribution in front here to take advantage of some of the features that CloudFront provides. So when to use FURLs? External APIs, there's no internal support today. If you need to invoke your Lambda function internally, you can use the AWS SDK or some other integration. Synchronous interactions. You can also support extended responses for up to 15 minutes. If you come talk to me about that one, though, I'm going to ask what you're doing, right? So I do occasionally work with customers that have legacy workloads that have synchronous interactions that last for more than 30 seconds. It happens. But I'd encourage you to think about that subscription pattern or some other ways to deal with that than just having the client sitting there spinning its wheels for 30 seconds or a minute. Furl support public, right? It's out there on the internet. Anybody can call it. Or AWS IAM is its authorization options. Or you can include whatever checks you need to do in the function code itself, right? But then you're kind of mixing a little bit. So if you really want to keep things separate, again, CloudFront or some other options. Patterns that we see with function URLs, people will use web frameworks, things like Fast API, or if it's just a simple single function type of service. So with that, I'm going to hand it back to Arthi to walk you through the completed plugin and a few finishing notes.
So this is the end-to-end architecture for the Leaderboard plugin. And we've used 3 different API architecture styles here. We've used async API with Amazon Event Bridge to ingest the metrics. We're using REST with Amazon VPC Lattice for our internal VPC-based metrics tracking service. And finally, we're using GraphQL with AWS AppSync for our public-facing API that is accessed by mobile applications and other devices. So key takeaways from our talk today. Let the business use case and API management needs drive the choice of the API technology. If you start by comparing API services as the first step, it is easy to get overwhelmed with options. Consider a managed service first based on your requirements, as this will simplify operations. Adopt a mental model of patterns to identify API solutions that work for common workloads. Codify them as infrastructure as code blueprints. And finally, adopt a product mindset while designing your APIs, because this will automatically encourage you to think about the developer experience, and a good developer experience will accelerate service adoption. So we made all the resources we used in our talk today available on the link you see at the bottom of the screen. There is also a sample implementation of the end-to-end Leaderboard plugin that you can find on the GitHub repository for serverless video. So do check it out after the talk. And here are some other API-related sessions that you might find interesting. The first one, which front door to use, is a chalk talk that takes a close look at API technologies, including some of the services we covered today. I didn't know API Gateway did that is a breakout that takes a close look at the features of Amazon API Gateway. And finally, the last one, designing your serverless API workloads for massive scale, is also a chalk talk that shows you how to scale the API Gateway Lambda DynamoDB pattern to handle large volumes of traffic. Visit AWS Skill Builder to discover free digital learning courses. You can also earn badges to demonstrate your expertise in specific domains. We have 2 badges for serverless. In fact, we announced the events and workflow badge only last week. The second one, of course, is the serverless badge. The link on the screen will take you to a consolidated list of all serverless learning resources. And that wraps up our talk. Please do take a minute to fill in the session survey. And Josh and I would like to thank you for joining us today.